Our topic for today is how to find the domain and range of rational function. In simplest form, the domain is all the values that go into a function, and the range is all the values that come out. So here's an example. When the function f of x is equals to x squared is given the values x is equals to set of 1, 2, 3, and etc., then the range is a set of 1, 4, 9, and so on. Okay, so we will find the domain and the range of fx is equals to 1 all over x. So the domain and the range of f of x is equals to 1 all over x is all real numbers except 0. Why 0? Because if ilalat natin yung x natin as to 0, 1 divide 0 is equals to undefined. Undefined, or kapag isolve natin sa calculator, 1 divide 0 is equals to error. Okay? So, if 0 naman divide 1 is equals to 0. Okay? So, yung ating domain and range would be all real numbers except lang sa 0. Okay? So, the domain would be domain of 1 all over x is equals to set of all x that are member of real numbers such that x must not equal to 0. Then, i-close natin. So, yan po ang kanyang domain. Okay, so how to read it again? Domain of 1 all over x is equals to set of all x that are members of real numbers such that x must not equal to 0. Okay, so except lang natin sa 0. To find the range, ganun pa rin siya. Range all over 1 all over x is equals to set of all f of x, or yung function niya is a member of all real numbers such that f of x must not equal to 0. Example number 2. Find the domain and range of g of x is equals to 1 all over x minus 1. Okay, so the domain and the range of 1 all over x minus 1 is all real numbers except 1. Why except 1? Because if we let x is equals to 1, our function would be 1 all over 1 minus 1. If 1 all over 1 minus 1 is equals to 0, 1 divided 0 is undefined. Okay, so undefined. So, except natin sa 1. So, yung domain and range natin will be all real numbers except 1 because x is equals to 1. It would make the function undefined. Okay, so we use the set builder notation. Domain of g of x is equal to a set of all x that are a member of all real numbers such that x must not equal to 1. So that would be our domain, and our range would be g of x is equals to set of g of x, which is our function, is a member of all real numbers such that g of x must not equal to 1 and close. Number 3, the domain and range of g of x is equals to 1 all over x plus 2 is all real numbers except negative 2. Why negative 2? If we let x is equals to negative 2, 1 all over negative 2 plus 2 is equals to 1 all over 0. That would make our function undefined. Okay, so our domain would be all real numbers except negative 2. We can also write this as domain of g of x is equals to set of all x that are member of real numbers such that x must not equal to negative 2. And for the range of g of x is equals to our function which is g of x, are member of real numbers such that g of x must not equal to negative 2. Example, find the domain and range of f of x is equals to x all over x squared minus 16. Okay, so the domain and the range of this function is all real numbers except negative 4 and positive 4. Why? Because if we let x is equals to 4, okay, so let's try 4 all over 4 squared minus 16. So 4 would be 16 minus 16. 4 all over 0, that would make our equation undefined. For negative 4, so negative 4 all over negative 4 squared minus 16. So negative 4 times negative 4 is also positive 16. So 16 minus 16 is 0. 4 divide 0, that would make our function undefined. So we can also write this as domain of function f of x is equals to set of all x that are member of all real numbers such that x must not equal to 4 and x must not equal to negative 4. Then close natin. To find the range of f of x is equals to set of our function f of x is a member of all real numbers such that function x must not equal to 4 and function of x must not equal to negative 4.